Welcome to this explainer. Okay, if you follow the electric vehicle industry, you already know we are dealing with a massive bottleneck when it comes to the green energy transition, and that's charging infrastructure. We all know EVs are the future, right? But the way we actually charge them right now, well, it's about to undergo a totally radical transformation, and I'm really excited to unpack this for you today. Okay, let's dive right into this. Think about it. For over a century, literally since the dawn of the gasoline car, we've all been completely conditioned to accept this filling station model. You know the drill. Your car is low on energy, you deviate from your route, you drive to a specific location, and then you just sit there and wait. But what happens if we completely flip that assumption on its head? What if, instead of the car going to the charger comes to you? That single question is sparking an absolute revolution in the industry. So here is our roadmap for today. We're going to cover 1. The EV charging bottleneck, 2. Portable power on demand, 3. Peer-to-peer EV charging, 4. Autonomous robotic charging valets, 5. Ceiling rail charging systems, and 6. A new paradigm for EVs. All right, let's get into it.
Section 1. The EV charging bottleneck, the stationary problem.
And Section 2. Portable power on demand, carrying the charge. So the crucial point here is this number, 3.45 kilowatt hours. That is the massive amount of usable energy a company called SparkCharge has managed to pack into a single unit called the Roadie Portable. Now, it weighs 70 pounds, so, maybe skip arm day at the gym if you're lugging it around. But this is really serious commercial hardware designed for instant off-grid range.
Because this system is entirely modular, it beautifully bypasses the whole traditional infrastructure headache. It actually operates as a 20 kilowatt DC fast charger, delivering roughly 1 mile of range for every minute it's charging. Plus, businesses can stack up to 4 of these batteries together to deliver up to 60 miles of range in just a single session. And the real beauty here? It's the plug-and-play operation. There are 0 electrical grid upgrades needed. A roadside assistance vehicle or, say, a fleet manager can literally just roll this thing out, plug it in, and deliver range completely on the go.
Section 3. Peer-to-peer EV charging. Cars charging cars.
And this brilliantly illustrates what happens when we just remove the charging station entirely. This block diagram from the International Journal for Research Trends and Innovation maps out exactly how a vehicle-to-vehicle, or V2V system works. Basically, a donor car transfers energy directly to a receiver car via DC-to-DC energy transfer. It cuts out the middleman entirely. No charging station, no centralized grid, just 2 cars solving the problem together.
Now, to ground this academic research in reality, let's look at the actual circuitry for Vehicle 1 and Vehicle 2. This is a real, working prototype built with ESP8266 microcontrollers, LM2596 buck converters, which step down the voltage, and relay modules acting as physical switches. So the 2 cars communicate via the Blink IoT platform over Wi-Fi, executing this digital handshake to constantly monitor the voltage, the temperature, and the battery state of charge. And it's super smart. If anything gets too hot or if the donor car's battery drops too low, the system just automatically cuts the connection.
But we do have to look at the real-world data neutrally here. This study actually found that the total efficiency of this B2B charging system is currently sitting right around 50%. This is primarily due to conversion losses as the power moves through those DC-DC converters, plus the internal resistance in the batteries and wiring. So while peer-to-peer charging is incredibly promising for things like emergency roadside assistance and totally decentralizing the grid, the engineering still has a little way to go to become highly efficient.
Let's move to Section 4 and see how this builds. Autonomous robotic charging valets. Enter the robots.
Imagine this user experience for a second. This is being developed by Bosch and VW software subsidiary Cariad. Step 1. You just drop your car off at the entrance of a parking garage. Step 2. You press a button on a smartphone app. Step 3. Your car drives itself away and parks autonomously in an empty bay. And Step 4. A mobile robot charger just wheels itself right over to your car, opens the charging flap, and plugs it in. It brilliantly solves the massive headache of fully charged EVs hogging the chargers all day. Plus, it's essentially a valet that never adjusts your mirrors or, expects a tip.
To really understand the scale of these robots, take a look at the X-Caddy lineup from Renault. They scale dramatically depending on what you need. You've got the Agile S1 models, which weigh around a ton and hold 80 kilowatt hours of energy, perfect to zip around and charge individual cars. But then you scale all the way up to the massive L1 model. At 47 tons and holding a staggering 3,000 kilowatt hours, that unit isn't just a charger anymore. It acts as a mobile peak buffer and a remote energy storage system. It is a complete, fundamental reimagining of how we deploy power.
Section 5. Ceiling rail charging systems. Overhead innovation.
If you thought the ground robots were cool, the contrast here is absolutely staggering. This is basically science fiction becoming reality in China right now. The old way means spending hundreds of thousands of dollars wiring individual spots, losing really valuable floor space, and relying on drivers to manually plug and unplug. The new way? You install one overhead rail that serves an entire row of parking spaces. It uses literally zero floor space, causes zero traffic conflicts, and a suspended robot simply glides over and plugs the car in automatically. It essentially turns every single parking space in a garage into a potential charger, without the insane cost of installing individual units at each and every spot.
So, let's look at the mechanics of this Chinese overhead rail advantage. When an EV owner parks, they just scan a QR code or use a WeChat mini program to request a charge. Then, this robotic unit, which is suspended from a ceiling track, and that track actually doubles as the power conduit, glides right over to the vehicle. It uses advanced sensor arrays and vision systems to precisely locate the charging port and then lowers a flexible arm to plug in. Now, because it uses the rail for power delivery, it's typically level 2 AC charging, meaning it is definitely slower than a DC fast charger. But for cars parked for hours at a mall or overnight in an apartment building, it is absolutely the perfect cost-effective solution. And companies like Li Auto and Wawaza Charging are the ones really leading this incredible push.
Now, what's really interesting about this slide is the sheer economic scale. Grounding all this futuristic tech with hard market reality proves we are not just talking about cool prototypes anymore. The global mobile charging robot market was valued at about $81 million in 2025, but by 2034, projections show a massive jump to over $300 million. And right now, China commands a massive 34% of that global market share. The economic incentives to get chargers off the ground and onto automated rails or robots, they are simply too big to ignore.
Section 6. A new paradigm for EVs, moving beyond the pump. By shifting our mindset toward modular batteries, peer-to-peer sharing, and these robotic valets, we are literally dismantling the infrastructure bottleneck. We're removing the floor space constraints of tight garages. And most importantly, we are erasing range anxiety by ensuring that power can dynamically meet the vehicle exactly where it is. So I want to leave you with a provocative question. With chargers now fully capable of driving, rolling, or gliding directly to our cars on demand, is the century-old traditional filling station model officially dead? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you in the next one.